Now we'll discuss about an important concept in gravitation, which is known as gravitational field. So basically, gravitational field is nothing but the region where a mass can experience some gravitational force. So by definition, we can say that gravitational field is the region where a mass can experience some gravitational force. It means that suppose if we are just considering a region and we are saying that over here gravitational force is acting, that means, or gravitational field is acting, that means if you are just keeping an object of mass m over here, if gravitational field is existing, then definitely this mass should experience some gravitational force. So if mass is able to experience some gravitational force, so we can say that in this region there is some gravitational field is existing. Now if there is some gravitational field is existing, so we are going to find out what about the magnitude as well as direction of this gravitational field. So the magnitude of gravitational field, that will generally represented by gravitational field strength, that is represented by gravitational field strength, or it is also known as nothing but intensity of gravitational field. So the strength of gravitational field or gravitational field intensity is defined as the force experienced by a unit mass. That means, as we already discussed, if you are considering a region where some gravitational field is existing, and if you are keeping an object of mass m over here, let's say it is experiencing some gravitational force F. So if on an object of mass m, if gravitational force is experiencing, gravitational field is experiencing or exerting a force F, so we can say that on an object of mass 1 kilogram, it will exert a force which is equal to nothing but F divided by m. So on m kilogram, it is exerting a force F. So on 1 kilogram, it will exert a force of F by m. So this F divided by m, force per unit mass, will give the strength of gravitational field. And as this gravitational field is a vector quantity, and the direction of this gravitational field is along the direction of force. So we can say that gravitational field is a vector quantity and its direction is the direction along which the force is acting on the object. So as we discussed, if there is some gravitational field and if you are keeping some mass m over here, it will be able to experience some force F. So we can say the same thing in another way. If we are saying that there is some gravitational field is existing, and let's say this gravitational field is having magnitude which is represented by, take it as G, where G is representing gravitational field intensity or gravitational field strength, and direction is represented by this arrow. So that means if you are keeping an object of mass 1 kilogram, it will experience a force that is equal to G Newton. So if you are keeping an object of mass m on this gravitational field, so this mass will experience a force. So we can write that force will be equal to m into G. So if there is existing some gravitational field, and in that gravitational field, if you are keeping an object of mass m, so that mass m will experience a force F, which is equal to the product of mass of object into acceleration due to gravity. It is also known as gravitational field strength, and the direction of that force is along the direction of gravitational field. Dimensional formula for gravitational field strength or acceleration due to gravity is, we know that this gravitational field strength is force divided by mass. So we can write force is ml t raised to minus 2 divided by mass, we can take it as m. So we can write it as L t raised to minus 2, which is similar to the dimensional formula for acceleration. And even we can write its SI unit, which is Newton per kilogram, force per mass, or Newton kilogram raised to minus